Our sun is now behaving even more violently than scientists had previously predicted. A surprising announcement from scientists involved in monitoring the solar cycle has confirmed that the sun's most active and dangerous phase, known as the solar maximum, is already well underway, and the worst may still be yet to come. New observations suggest that the number of sunspots on the sun's surface is rising much faster than predicted, which has raised concerns among scientists. Researchers are now claiming that the rapid increase in sunspots is a matter of concern, as it could lead to intense solar flares. NASA has predicted that the sun will be even more active in the year 2025, and recent observations have raised further concerns about the impact of this solar activity on Earth. So, what have scientists discovered in their latest observations? Why are they so concerned about the rapid increase in sunspots? And how will powerful solar flares affect Earth in 2025? Let's find out in this video. Sunspots and solar flare sunspots are areas on the sun's surface, known as the photosphere, where the temperature is significantly lower than the surrounding regions. While the average temperature of the sun's surface is about 5,500 degrees Celsius, sunspots can be as cool as 3,800 degrees Celsius. This cooler temperature makes them appear darker, although they still emit light. Sunspots are only dark in contrast to the bright face of the sun. If you could cut an average sunspot out of the sun and place it elsewhere in the night sky, it would be about as bright as the full moon. The formation of sunspots is linked to the sun's complex and ever-changing magnetic field. The sun is composed of hot plasma, and different parts of it rotate at different speeds. The equator of the sun spins faster than the poles, causing the magnetic field lines to twist and stretch over time. When the magnetic field becomes highly concentrated in one area, it prevents the normal flow of hot plasma from rising to the sun's surface. This results in a region that cools down compared to the rest of the sun. Since cooler areas emit less light, sunspots appear darker than the surrounding surface. These spots can last for a few days or several months, forming in cycles that correspond with the sun's magnetic activity. Are these sunspots a threat to Earth? Well, sunspots aren't dangerous on their own, but they can lead to something much more powerful: solar flares. When the magnetic field around sunspots becomes too tangled or unstable, it can suddenly snap, releasing a huge burst of energy in the form of a solar flare. This process is similar to a rubber band being twisted until it finally breaks and releases all of its stored energy at once. Solar flares are classified by their intensity, with the most powerful ones being X-class flares. These are incredibly energetic and can release as much energy as billions of atomic bombs. Recent data shows that as of October 4, 2024, Earth has been hit by 42 X-class solar flares this year. What's even more concerning is that the strength of these solar flares has been increasing, and scientists believe we could see even more powerful flares in 2025. Why are solar flares becoming more intense? The increase in solar flares and sunspots is part of the sun's natural cycle. Every 11 years or so, the sun's magnetic field completely flips, meaning the sun's north and south poles switch places. This solar cycle affects activity on the surface of the sun, including the number of sunspots, which rises and falls throughout the cycle. There are two main phases of the solar cycle: the solar minimum and the solar maximum. One way to track the solar cycle is by counting the number of sunspots. The beginning of a solar cycle is known as the solar minimum, when the sun has the fewest sunspots. Over time, solar activity and the number of sunspots increase, reaching the solar maximum at the midpoint of the cycle when the sun has the most sunspots. As the cycle ends, it fades back to the solar minimum, and then a new cycle begins. Here, you can see the increase in the number of sunspots during the solar maximum phases of 2001, compared to the weaker phases of 1996 or 2006. Almost a century ago, Swiss astronomer Max Waldmeier left a trail of cosmic clues that scientists still follow today to predict when the sun will reach its solar maximum. Back in 1935, Waldmeier noticed something fascinating about sunspot cycles. The faster the rise of a sunspot cycle, the stronger its strength. He realized that a stronger cycle took less time to reach its maximum strength. This discovery, now known as the Waldmeier effect, helps scientists estimate the strength of a sunspot cycle by observing its early stages of development. Using this method, NASA scientists predicted that the next solar maximum would occur in 2025. However, scientists have recently observed new data revealing that the sun is becoming more active than they originally expected, leading to growing concerns. Here, you can see a graph tracking the number of sunspots over recent months. The black line represents the actual number of sunspots observed each month, gathered using telescopes and satellites. Around 2019 to 2020, there was a sharp increase in sunspots, indicating that the sun is growing more active as this cycle progresses. The purple line shows the smoothed sunspot numbers, which are averages taken over several months. This helps smooth out short-term fluctuations and gives a clearer view of the longer-term trends. The red line represents the predicted number of sunspots for solar cycle 25 based on past cycles. These predictions help scientists anticipate how active the sun will be over the next few years. Finally, the gray shaded area around the red line represents the uncertainty in these predictions, as solar cycles can be unpredictable. This shaded area reflects the possible range of sunspot activity from the highest to the lowest expected values. Recent observations have shown that the number of sunspots is rising faster than expected, which is concerning. In the past, a faster rise in sunspot activity has often been linked to stronger solar cycles. Because of this, scientists are increasingly concerned about how solar cycle 25 could impact Earth. As we move closer to the peak of solar cycle 25, expected around 2025, the number of solar storms and sunspots is likely to rise sharply, along with the likelihood of large solar storms. These storms can have far-reaching consequences for Earth. When solar flares or coronal mass ejections reach Earth, they interact with the planet's magnetic field, causing geomagnetic storms. These storms can disrupt satellite communications, knock out power grids, and interfere with GPS signals, which many industries rely on for everything from navigation to timing systems in financial markets. To understand the potential danger of these solar storms, we can look at historical examples of how large solar events have affected Earth. The most famous instance is the Carrington event of 1859, the largest recorded geomagnetic storm in history. During this event, a massive coronal mass ejection struck Earth, creating auroras visible as far south as the Caribbean. Telegraph systems, the main communication technology of the time, were severely affected. Some telegraph operators reported sparks flying from their equipment, and in some cases, telegraph lines continued to transmit signals even after being disconnected from their power sources due to induced electric currents. If a similar storm were to happen today, the impacts would be far more severe. Modern society is deeply dependent on technology, particularly satellites, electrical grids, and telecommunication systems. A storm of the Carrington event's magnitude could damage satellites, disrupt aviation systems, affect global communication networks, and cause widespread power outages. Given the rapid increase in sunspots during solar cycle 25, scientists are concerned that a similarly large solar storm could occur in the next few years. Although solar cycle 25 is not predicted to be as extreme as some past cycles, the faster-than-expected rise in sunspot numbers suggests it could still produce significant solar storms. As we approach the peak of the cycle around 2025, governments and industries are paying close attention to space weather forecasts to mitigate the risks posed by increased solar activity. Preparing for the possibility of large solar storms is crucial to protecting modern infrastructure from potentially devastating impacts.